Hello and welcome. So before we start the section where we do the part placement holder for the VFDs, there's two things that I want to actually speak about, and there's two devices that I want to speak about. It's actually not points, but devices that I want to speak about. And I actually want to make sure that you guys understand the reason why we have this output from Siemens Simaris design. So this is the output from Siemens Simaris design. You do not need to pull yours up. We can actually look at this one that I have right here. So I just want to speak about two things, two devices, which is your motor protection circuit breaker and also your contactor. So maybe you might be wondering, you have actually analyzed this document. Maybe you might be wondering, why is it a little bit different with regards to the VFDs? So I want to actually speak about that. So I'm going to speak about the motor protection circuit breaker and the contactor. So I will zoom in. This is the section we have right here for our VFDs. So I'm going to zoom in to here so that I can get them in screen. And I'll just move a little bit to the top. Let's move to there and we'll have them like that. So these are our VFDs right here. You can see this are our VFDs. These are our direct online and these are our ventilation fans. So now the focus is on the VFDs. So what you will notice is that with the VFDs, we actually have the circuit breaker right here. So these are the motor protection circuit breakers we have right here. You can see that Siemens Simaris design, it's actually suggesting us to use the circuit breaker and to have the switch settings of the circuit breaker at 45 amps. So the IN should be 45, it should be 45, it should be 45, and this one should be 32. So the first thing that you would notice is that you see that 32 right there and you see this 11.5. So that difference there right there, it's not actually a buffer to say that we actually want to have a buffer from the rated current of the motor and the rated current of the circuit breaker. So it's actually not the buffer for that. So that's why we have such a large difference. So you can see with the direct online, it's actually 3.2 right here, and this one is 2.1. We actually have that buffer so that we do not have any or a lot of tripping between when we start our motor or when you're running it or anything like that. So we actually just increase it a little bit. Sometimes it's by 125% or 1.25. We actually just increase it based on the motor. We just multiply by 1.25. But when you're working with the VFDs, we actually do not do that. We actually do not look at our motor and then rate this one based on our motor. But what happens is that you need to rate it based on the input current of the VFD. So I actually have a note for you guys. I actually have a note and you guys can review this note as well. So on this document, this is the document for the Welding Robot Station 01. This is the switch settings document. So I've actually attached it and you guys can actually look at this note. So this note in orange, you can see right here, I've written something for you guys and you guys will be able to understand how we actually rate the motor protection circuit breaker when we're using a VFD. So what I said right here is that the motor protection circuit breaker, it is used to protect the VFD input. So it's used to protect the VFD input. It's not used to protect the motor. So you shouldn't rate it according to the motor current. So that's very important when you're using the VFD to not rate your motor protection circuit breaker according to your motor's current. So it should be for your VFD input. And then I also go on here and I say the motor protection circuit breakers IR setting should be accommodating the VFD's in nominal input current while allowing for inrush and avoiding tripping. So that's why I say sometimes we have that 1.25 buffer or something like that so that we avoid having a lot of tripping when we start or having inrush current or anything like that. We actually have that times 1.25 or something like that. So 125%. So you should be careful of that. You should be careful of this. This is a very important note. That's why we actually have that difference when you see it in the PDF document, that output from Siemens Simaris design. So we see this one is 45, but you see this one, it's actually 15.2. So this one is 15.2, this one is 22.6, but you can see it says here we need to set it at 45. So it's actually looking at the VFD. It's not looking at our motor, but it's looking at the VFD. Then the VFD will actually be responsible for protecting our motor. So that's the one thing that you should also note, that the VFD will be then responsible for protecting our motor. So as an example right here, I also say that if the VFD's input current is 26 amp, a setting, so the setting for the motor protection circuit breaker, the IR should be slightly above. For example, it can be 30 to 35. So it's typically applicable or appreciated. So you can have it around that setting. So that's the setting you can use it. However, I carry on, I say, however, the motor protection circuit breaker does not provide motor overload protection. Instead, the motor protection circuit breaker can be configured, or the motor protection, not the motor protection circuit breaker, but the protection for the motor can be configured in the VFD itself. So in the VFD itself, you can buy an intelligent operating module. If I just look at it on the internet right now, you can see if ever we have this one, you can see this is the VFD that we're using. You can see that's the VFD that we're using. So inside the VFD, you can be able to connect on the VFD, not inside, but on the VFD, you are able to buy this module, and actually this is the intelligent operating panel. And then you can be able to do some settings, or you can be able to connect via Ethernet or via Profinet or via Profibus. You are able to connect to the VFD, and then you are able to set the settings that you require. So that will be the setting to protect the motor. So those will be the motor protection settings, so that you can do on the VFD. So the motor protection circuit breaker that we have, that's for the VFD, and then inside the VFD you can actually be able to configure for the protection of the motor, and then you will do that inside the VFD's parameters. So inside the VFD parameters you will be able to do that, and you will be able to select the appropriate thermal overload class. So typically a class 10, so you will be able to do that. So that you should be wary that you do it inside the VFD. So your guys, your technicians in the panel shop, or the PLC guy, or you are able to do that yourself as well. You are able to do the settings on the VFD and configure the parameters so that you are able to protect your motor. And then the second thing that you would note is that it's the contactor. So we have a contactor right here. So you can see these are the suggested contactors. So just be wary, these are the suggested contactors, and you can see the contactors, they are meant for switching. So you can see sometimes the contactors, they are below what the motor protection or the motor current rating is. So you can see this one, it's 20.6. But if you would search this part number on the internet, so this is the part number, you can search it on the internet. I've already searched it. So you can see if I open it right here, this is the part number. So what you would note with this part number is that it's a 9 amp. So you can see it's a 9 amp right there. And right there, you might be wondering, why would Siemens Simaris design give us a 9 amp, whereas our motor, it's actually rated at 20.6. So that's one of the other things that you need to be wary of, because contactor, it's actually located before the VFD. So we're actually using the contactor for switching. So it's not for protection. The contactor is not meant for protection in our circuit. It's meant for switching. It's only used for switching. So therefore, I also have a note with regards to that. I have a note in this document. This is a different document. It's not the same as the switching document. It's a different document. This one will be the one that we use when we actually create the part placement. But the note is right here. So you can see it's right here in the yellow. So you can see that it says, if I just zoom in a little bit, maybe so that you can see properly. Let me just zoom it out a little bit because it's just too big on my side. So I say that Siemens Simaris design expects the input side protection to be done primarily by the circuit breaker. So primarily by the motor protection circuit breaker, that should be the one that does the protection rather than the contactor. So the contactor does not do any protection, it just does the switching. So we use the line contactor, or we use the contactor on the line side low switch, and mainly it's for switching on, switching off control, and not primarily for overcurrent protection. And then I go on and I say that this approach matches Siemens recommendations. So breaker is for protection, and then the contactor is for control. And then also I'd say here, right here at line 11, I say the contactor is recommended for switching, but relies on the breaker for protection, just like I mentioned also earlier on. This combination ensures proper protection and control. So that's the standards of Siemens, and that's the standards of Siemens Simaris design, which is also basically just Siemens. And then at line number 12, I also do give some more information with regards to that the input side of the VFD usually has dedicated protection devices like the 3RV2 series motor protection circuit breaker, so which will handle the actual overload and the short circuit protection. The contactor's job is just switching, not protection. So I just need to emphasize that. I just need to make sure that you guys understand that concept. That concept, it's very important to understand it when you're actually doing VFDs. So once we have understood that concept, what we can do is that we can actually move on to EPLAN. In EPLAN, we will be able now to create the part placement without any questions of why is the circuit breaker rated at that, and why did Siemens Simaris design give us those type of ratings, and why is the contactor at 9 amp but the motor is rated at 20.6, and so forth. All that information that could cause confusion or anything that's like that. So therefore, you have that information for yourself. You have that information from me as well inside these Word documents or inside these Excel documents. So you have that information from me. You can see that's the information I gave you as well right there. So with that information, I'm happy that you guys will have an idea of why those ratings are like that. So once we have that information and we're happy with that information, we are going to move into EPLAN. So we're going to move into EPLAN and we're going to create the part placement holder. So I have created the macros project. You guys were able to open it. I've created the macros project. So what we're going to do for the VFDs, I'll just show you guys in the next lecture. What we're going to do is that we're going to just fill in some part numbers and also create the part placement holder. And therefore, on the lecture after that, we're going to actually put it inside our main project. So we're going to put it inside our main project, which is the welding robot station 01. We're going to put the part placement holder inside that. And we're actually going to do a lot of things, do a lot of changing and all that. So therefore, that's it for this lecture. That's it how we actually can be able to understand what Siemens Simaris design has given us with regards to the VFDs, and therefore we can move forward into EPLAN. So thanks very much for watching, and I'll see you guys in the next lecture.